एक काम कर, तुला ऐनवेळी जमेल का मी सर ना?
Yeah, I am Dr. Jaiswal, principal of this college. On the behalf of this college, I welcome to you, sir. I also welcome my colleagues and all students who are participating in this webinar. Good morning, students. First,
त्यांना आपण म्यूट केलेले.
First, I would like to introduce our today's speaker. It's my privilege to introduce Dr. Harishchandra Parbat, assistant professor in Wilson College, Mumbai. He has completed his MSc, PhD and qualified SET examination. He is a guide for PhD and also holding a membership of Board of Studies in University of Mumbai and University of Solapur. He wrote 5 books and he delivered 16 invited talks at different national and international level conferences. Dr. Parbat is a member of Indian Science Congress Association and Association of Chemistry Teachers. He has presented 6 research papers in different conferences, and so far up to this, he has published 12 research papers at national and international reputed journals. Today, is going to deliver a lecture on basic quantum chemistry. On the behalf of the college, welcome Dr. Parbat and hand over this mic to Dr. Parbat. Sir, please start your session.
Good morning, sir. आवाज येतोय ना sir? आवाज?
Yes.
Okay, good morning, honorable principal of this college, inviting for this online lecture on based on the platform Zoom. I think this is the opportunity to improve our knowledge, technology, and take the benefit of the technology. I think all friends are, student friends are staying at the home and they are safe. I think today we start the lecture based on the quantum chemistry. Okay, sir, I can share the 1 minute.
Yes, sir.
I will share this PowerPoint.
Yes, sir. Carry on.
Yes, sir. Yes. Okay, getting the screen, sir. Sir, screen this thing, barabar?
Yes.
Okay. I think I'll thank to the Anand sirs also because he's inviting me, and I'll thank to those are participant for this online lecture. Today we are talking about just quantum chemistry, basics of the quantum chemistry. I will not go to the detail. I want to create the interest in the subject of quantum chemistry. I think all students know we are studying the chemical thermodynamics, quantum chemistry. Okay, thermodynamics also you are studying, and in that also you are studying the energy of the molecules, energy of the particles. In quantum chemistry also you are studying the energy of the particle. Now, what is the difference between the quantum chemistry and chemical thermodynamics? In chemical thermodynamics, you are studying the energy of macro particles, means you can observe easily. Okay, but in quantum chemistry, you can study the energy of microparticles. Means those particles is not easily observed. Just electron, proton, neutron, whose the mass is 9.109 in 10 raised to minus 31 kilogram. It is a very smallest particle, but by using the quantum chemistry, you can study the easily. And that's why we are expressed in the form of to study the any particles. Suppose simple example, let us consider the hydrogen atom. Hydrogen atom have the two particles. Okay, mostly we consider only one particle, but have the two particles. Which two particles? One is the nucleus and one is the electron. Now in this, electron is the moving particle and nucleus is the stationary particle. Now that electron as a particle is in a which cell? Is a K cell, L cell, M cell, N cell. Means we will not get the information because of the small particle. It is difficult to observe, and that's why we are expressed in the form of wave function psi of, means expressed in the form of wave function, and that wave function is the information about the particle. So such like as if you express the any particle in the form of wave function, we express in the form of psi of xt. I think student friend don't take tension about this technology or this quantum chemistry is very difficult. Okay, I also come from the small village. Okay, and whatever the create the interest, and because of this interest, those subject is very difficult. Okay, that you get the good output. That's why you try to, what is the difficult subject you can usually try. Okay, so we are talking about wave function psi of xt, means to express the any information about the particle is expressed in the form of psi of xt. Now x is the displacement or distance and t is the time. Now this is the information of particle at that time. What is the position of the particle? Okay, simple. Now all students are there. Now you are at this time, what is your position? You are at the home, but is lockdown is not there, you are in the college. Means according to time your position is changed. That's why any particle to express in the form of psi of xt. Now there is a different functions, linear functions, exponential functions, trigonometric functions. Okay, that functions means wave functions, which you get the continuous wave functions, crest or trough. I think everybody know the crest is the positive amplitude, that is the crest, and if you have the negative amplitude, that is the trough. And neither positive or negative, and if that wave is on the nodal plane, means psi is equal to 0, that is called as the nodes or nodal plane. Now most important in the quantum chemistry is the eigenvalue equation. I think whole quantum chemistry is based on the eigenvalue equation. What is the eigenvalue equation? Simply h psi is equal to e psi. Now what is the h? H is the Hamilton operator, psi is the wave function, and e is the eigenvalue, and psi is the eigenfunction. It is very simple, this equation. When this operator h is operating the wave function, you get the another new function, and that new function, it is called as the eigenfunction. But when it is called as the eigenfunction, what is the coefficient? If that function is same as it is, and you get the new coefficient, or that is the real value. That real value is called as the eigenvalue, and we can say the energy, total energy of that particle, and psi is the eigenfunction. I'll tell you simple trick of this eigenvalue equation. Hamiltonian operator is the doctor, wave function is the patient. When doctor did the operation on the patient, if patient is alive, what is the condition of this equation? Patient should be alive. If patient is alive after operation, that patient is called as eigenfunction. And if he is alive, there are the two ways of energy, either positive or negative. But that energy should be real value. Means what is the condition? After operation, that patient should be alive. Then that is called as the eigenfunction, and you will get the eigenvalue is either negative or positive. This is a very simple eigenvalue equation and is converted to the Schrodinger. Okay, so today we will not go to the detail about that, but I will create the interest in the form of quantum chemistry. So just we are enter the some experiment in the Mumbai University for the master in physical chemistry, and it is very interesting. Simple example: graph plotting of mathematical functions, linear, exponential, and trigonometry, and identify whether they are acceptable or non-acceptable as wave functions. Everybody know wave functions are different types. Now, what is the condition of the acceptable and non-acceptable wave functions? I think you go to the any chowpatty or any beach, water waves also there. It is continuous or discontinuous. So if they have the three conditions for the acceptable wave function, first is function should be continuous. If wave function is continuous, continuous means crest drop, crest drop. Second condition is function should be single value. Means that x value should be either plus 1 or minus 1. It is not plus or minus 1 or more than 1. Single value. And third condition is function should be square integral, that is should be have the finite value for all the values of x. Means you cannot say my wave is infinite distance. Okay, that wave of the particle is infinite distance. You have to say the some finite value. These are the three conditions. If these three conditions are satisfied, that wave functions are acceptable. If any one condition is not satisfied, that wave function is a non-acceptable. With a simple example, you check the graph also. Left hand side, acceptable wave function. Okay, look about that. All these two are acceptable. And right hand side, non-acceptable wave function. Okay, so practically, how you sketch it? I think that we go to the, suppose first we'll use the trigonometric function. Everybody know trigonometric wave function, sine, cos, tan, cot, cosec, sec, whatever that. We don't have the required knowledge of mathematics. Don't worry about that. Simple function, f of x is equal to sine x. Okay, and we have to check this function is acceptable or non-acceptable wave function. So we can take the limit minus 360 degree to plus 360 degree, because that wave function is goes to the minus to plus 360 degree. And when you do the calculation, simple, that sine x in a degree, minus 360 minus 330 means take the 30 degree difference up to the 360 and calculate that by using the calculator f of x values. Now look about this f of x values. When you take the sine minus 360, 0, then you go to the 30 difference, 0.5, 0.86, 1, and then decrease. Look about these values. And last 360 plus 360 also 0. Now, when you sketch is this, when you sketch the wave function, look about this. Okay? If you get a minus 360, dekho, 0, then it has a positive value. When you come to the minus 180, again 0, and then is what you are the minus value. First is a 0 to plus values, 0.5, 0.86 something, minus 180 have the 0, then minus value, then again 0 at the 0, then positive, then plus 180, 0, then negative. Look about this function. If you plot it, this is experimental. Just you plot it. What is information about this? About mathematical function. Since above mathematical function, that is f of x is equal to sine x, is continuous. Everybody agree? Crest drop is a continuous. Single value is either positive or negative. Single value and finite for all the values of x. You substitute any x value, highest, lowest, any value. That value should be finite. And look about our finite value 0.5. What is that way? Means any finite for all the values of x. Hence, it is an acceptable wave function. This what is the condition? Continuous, single value, and it is finite for all x values. And look about that. This interested graph is got it. That is sine x is the acceptable wave function. Means is a well behavior. Acceptable means well behavior. There is a difference well behavior and non-well behavior. I think suppose student also well behavior or non-well behavior. If student is continuously coming to the college regular and have the target study, and his target is only to dream, I want to become this. No, that target should be finite, fixed. That's why that student is well behavior. means well-beer means acceptable. Same as to function. I think you go to the beach or chowpatty. If that wave you are starting on the end and wave is coming, crest up, and you will understood that wave is comes, is continuous. You get the information. That's why you will be away from that. No any effect. But if it is the wave is first crest, then nodal plane, then crest, means nodal plane, discontinue, and after that you are getting 5 feet. Means on the us. So that's why which wave function is acceptable, non-acceptable is very important to study. Second example, tan x. Tan x is f of x is equal to tan x. Everybody know how to calculate. First, look about that. First, you find out sin x, then find out cos x, and everybody know the tan x is. You take the ratio of that, you get the tan x. And this is the values. Okay. So what is the value you got it? Minus 360 tan x is 0, but minus 270 is infinite. And look about that. When you sketch it, look about that. Is finite and is infinite. Okay. So what is the observation from this graph? Since above mathematical function, that is f of x is equal to tan x, has infinite values for few values of x. Not all x values are infinite, but few values of x. Hence, it is not acceptable wave function. Now, if it is infinite, there is no continuity. Single value is there, but it's not continuous, and that's why. And there is no finite value also every x values, and that's why tan x is the non-acceptable wave function. I think we have discussed trigonometric function. Sin x is the acceptable wave function and tan x is the non-acceptable wave function. And if you know this way, you can solve maximum problems. Now we go to the exponential. Exponential as a wave function. First, f of x is equal to e raised to minus x square. Now you have to give the limit for the exponential. Minus infinity to plus infinity. So limit is such like as we are given to the student minus 2 to plus 2. You can give to the minus 4 to plus 4 also. And difference should give it 0.2, 0.4, 0.6. So we are given the difference 0.2, 0.2. Okay. So minus 2 to plus 2. And look about that x square. Take the first x square of that, all are positive, and then take the exponential. Please, when you take the exponential, second function shift and then natural log, ln. Then you will get e raised to minus x. Don't take exp, then you will get the wrong values. So exponential minus 2 is, look about that values. This value you get it and just sketch it. How is great or very nice graph. This is the student's output. I think we are saying this neither instrumental or non-instrumental experiment. We are saying the dry experiment. You don't require any solvent, solution, chemical, audio, or anything, or any instrument. You require only calculator. And what you are theoretically we are studying, we don't understand only what is meaning of acceptable or non-acceptable. When you sketch it, I think it is very easy to understood. Okay. So this wave function, since above mathematical function, that is f of x is equal to exponential minus x square, is continuous. Okay, is a continuous. Then have the single value and finite for all the values of x. It is finite. So as x equal to infinity, f of x is 0. अभी आप बोलेंगे यार -2 to +2 लिया इसलिए infinite आया. But you can take the x equal to infinity. So f of x is equal to 0. Hence, it is an acceptable wave function. Means this exponential also acceptable. Now, if you take the positive e raised to plus x square, okay, e raised to plus x square. Calculate the value of x square, e raised to plus x square, and look about that as values. Okay, and sketch it. Okay, so your reverse will get positive there. Reverse. Okay, so what is the conclusion we'll get? Since above mathematical function, that is f of x is equal to exponential plus x square, is a continuous single values for all the values of x. However, when x is infinity, f of x is infinity. That's the problem. It is continuous single value, but when you take the x is equal to infinity, that f of x is equal to infinity. And that's why all these two conditions is satisfied. But every that f of x is not finite, means it should be finite each and every x values. But here what is problem? When you take the f of x is infinity, that value is infinity. So hence it is not acceptable wave function. Please take care. Don't go to the only continuous single value. You have to check f of x is equal to infinity, because here we are not taking infinity, because for calculation, easy calculation, minus 2 to plus 2. But you try to take f of infinity, then check it, infinity square, exponential of infinity. If it is comes significant value, finite, then is continuous, then is acceptable. But here is not acceptable because of the only reason f of x is equal to infinity. Now, slightly complicated function. We cannot say complicated because you have to use the only calculator and check it. So look about this. This function f of x is equal to e raised to minus x square upon 1 plus 1 upon e raised to x. And limit is same, minus 2 to plus 2. Take the values. This value is there, but you have to go to the step by step. Take the x square, then exponential of minus x square, 1 by x, exponential of 1 by x, and then you calculate the 1 plus exponential of 1 by x denominator, and then numerator, where is the numerator? Exponential minus x square, this is the column, and denominator is this. This column divided by this column, you get the f of x. And look about these values and sketch it. Now what is here? Minus 2 are the 0 value, and then you go to the 1. This here 1 is there, approximately 1.95 something, and then directly is come down 0 point something. Okay, so I think very simple from this observation. Above mathematical function single value but discontinuous. देखो here is going to the high approximately 1 and then is come down, is not continuous. Okay, so gap is there, that's why the discontinue. Means here we are given the information, single value का भी दिया है, finite का दिया है, and this is based on the continuous. This function is not continuous. Means continue or non-continuous. Continuous रहेगा तो will be positive, non-continuous रहेगा तो is non-acceptable. So this function is non-acceptable is because of the only it's that wave function is non-continuous. Okay. Now this is just wave function. Now when you express the particle is psi of x, y, z. Means psi of x, psi of y, psi of z. Psi of x is there one dimensional along the x axis. Psi of x, y is there two dimensional along the x as well as y axis. And the psi of x, y, z is there three dimensional. Is particle along x, y as well as z axis. Okay, but now some of the particles is not along the x, y, z axis. That is in between the axis. Why I'm saying this? Because when you study the inorganic chemistry, orbitals, S, P, D orbitals. Now S orbital is a spherical shape. Is not on the x, y, z axis. That is in between the axis, and that is called as the polar coordinates. If its particle is along the x, y, z axis, it is called as the Cartesian coordinates. But its particle is moving around the nucleus. Electron is moving around the nucleus. So that is not along the Cartesian coordinates. That is polar coordinate. And polar coordinate is expressed in the form of psi of r theta phi. Now instead of psi of x, y, z, I will express psi of r theta phi. R is the radial wave function, theta zenith wave function, phi is the azimuthal wave function. Now R is the radial, means radial nodes, which you get the orbitals, 5s, 4s, 3s, 2s, radius of that orbital. And theta and phi is the zenith and azimuthal angle. You will get the angular distribution, angle. So everybody know the shape of the orbitals, but how you get the actual shape? I think most of the student or teacher also don't know how to get the shape and what you are studying the quantum chemistry. So this also we are including the syllabus, and I'm very happy because Mumbai University given the chance to as the board of studies member, and that's why most of the syllabus we are finalized. And according to that, this experiment also included for the MSc. What is the experiment? Polar plots of atomic orbitals such as 1s, 2pz, 3dz square orbitals by using angular part of hydrogen atom wave function. What you are saying? S orbital is the spherical shape. P orbital is dumbbell shape. D orbital is double dumbbell shape, or what is another shape? You can, I will observe that. I will give that information. So you are saying, but how you get? So that we have to look over here. So theoretical background is what I told, psi of r theta phi. Means wave function is expressed in the form of polar coordinates. Okay, I think simple. When you are in the school time, just like as first standard, second standard, your parent is known. You are in a which position. आप घर से भी बाहर निकलते तो इधर फिक्स पोजीशन होता था आपके फ्रेंड के घर इधर उधर साइड पे. Now अभी आप बड़े पार्टिकल हो गए. Now you are moving. I think if parent is searching for you, you will not get the idea where you are you, because you are moving 360 degree. Any position. Now is not fixed is XYZ. Now is the along the 360 degree. So same as here, particle is particle on a sphere, or electron is a particle moving around the nucleus, and that's why expressed in the form of psi of r theta phi. Okay, if you separate, r of r is a radial component and r of theta phi is the angular component, and based on angular component we solve the some problem. Very interested. I think this is everybody know the spherical shape, and 0, 90, 180, 270 and 360. This is a graph paper. Now give the scale. Okay, and there is a nucleus, first circle, second, third, fourth, 5. Means suppose we'll go to the first 2pz orbital first. Okay, everybody know 2px, 2py and 2pz. But when you are writing, there is some quantum numbers. L is 1. L is 1. Means azimuthal quantum number is 1 or 2. Abhi S, P, D, F. Yes, L azimuthal quantum number 0, P have the 1, and D is 2. So here 2pz is there, P means L is 1, azimuthal quantum number 1. Magnetic quantum number. Listen, this is very important. There is principal, magnetic and azimuthal quantum number. Now it is difficult to separate. Suppose 2s0, 2p0, 2p plus 1, 2p minus 1. You cannot separate by using the principal quantum number, because all 4 orbital principal quantum number is same, 2, 2, 2. Then you come to the azimuthal quantum number. So all 3 p is 1, s is 0. You only separate s and p, but you cannot separate 2p0, 2p plus 1, 2p minus 1. That time you apply the external magnetic field. That is the magnetic quantum number. So 2p plus 1 is above, 2p0 on nodal plane, and 2p minus is on the below. Okay, you can separate only any orbitals according to energy levels, which called as a Zeeman splitting also. That is based on the magnetic quantum number. Okay, so function is 2pz orbital, f of theta is cos theta. That you have to keep in mind. F of theta is equal to cos theta. Now we'll give the 0 to whatever the degrees. You can take any up to the 360 degree. Okay, 0 to 360. And difference is 15. You want to take 20, you want to take 30, you want to take anything. So according to that, is f of cos theta is 0. Listen, cos 0. If theta is 0, cos 0 is 1. Then you come 15.97. And when is 90, 0. Then minus. Okay? Then 270, 0. Then 360 again 0. Plus minus. And look about this. Now your value is maximum 1, minimum 0. So have the 1, 2, 3, 4, 5. So each circle you have to take the scale. One circle is equal to 0.2. So 0.2, 0.4, 0.6, 0.8, 1. Now by using the values, sketch it. 0, 0. देखो 0 का वैल्यू सॉरी 0 का वैल्यू कितना है 0.2, 0.4, 0.6, 0.8, 1 है. उसके बाद 15.97. Then you come to the next 90 डिग्री पे देखो 0 आया है. उसके बाद नेगेटिव है 180 पे देखो 0. उसके सॉरी 180 पे क्या है -1 है 180 पे ये साइड आएगा -1. Then you come to the 165 sorry then down 195 to 110. Okay, and then 270 again 0. Okay, and then come to the means look about that 4 Cartesian coordinates. The quadruple is there, first, second, third, fourth. What is the positive, negative value you have to keep in mind? So according to that 4 values 0 है. 0 पे sorry 0 पे 1 है, 90 पे 0 है, 180 पे -1 है, then 270 पे 0 है, and 360 पे that way. So you have to sketch it and look about the shape of the orbital. What is the shape of the orbital? It is dumbbell shape. Listen, when you sketch on the board or on the paper, we are not sketching this way. Actually, that is theoretical. We are not understood. It is a very wrong. We are sketching. Look about that center, positive or negative is there. At the positive is the highest probability of electron cloud. That is called as the maximum probability. अपना क्या होता है? When you draw it, dumbbell shape कैसा आता है? Is not matched according to size. Means here last में 0 होना चाहिए and first में nodal पे line पे आने चाहिए, nodal पे. And center on that nucleus center plus or minus, there should have the high probability. It is called as the maximum probability of electron cloud. When your electron is moving around the nucleus, that cloud, probability of that electron cloud. Okay, this is 2pz orbital. We come to the next orbital, that is 3dz square. Because S, 1s, P start from 2p, 2px, 2py, 2pz, and D start from 3. So 3dx, 3dy, 3dz. Sorry, dxy, dyz, dxz, and dx square, y square, and dz square. So what is the important